Hello all, this is Vignesh. Welcome back to my YouTube channel. Here we're gonna discuss today about the reinforcement learning with human feedback in case of particularly with large language models. So here particularly if we see along with the large language models which we can develop from scratch for any casual language model for that matter, we'll be predicting the next token is what is the basic methodology which is happening. So if you see BERT, Robert, DBERT, these kind of transformers, these are encoder based models. So this consists of the basically the transformer consists of the both encoder and decoder, and these models consist of only encoder. So there comes the models like ChatGPT, which are generative models, where these models consist of the only decoder, and there is a kind of generative model such as T5, which consists of the both encoder and decoder. So specifically, if we use the architecture like ChatGPT or any other generative model, we will be also using the reinforcement learning with the human feedback. So based on that process, there is a algorithm which is a PPO, proximal policy optimization, which is the algorithm being used used for the reinforcement learning with the human feedback. So what happens exactly is basically we'll collect the human feedback, and first we will train the model. PPO is nothing but the proximal policy optimization. So this generally reinforcement learning with human feedback consists of the three major steps. So if you see this majorly consists of the first step is the supervised fine-tuning model. So this fine-tuning model, supervised fine-tuning model will be done in the first step. If you see, so exactly we will be performing the supervised fine-tuning here based on the summary selection. So once that supervised fine-tuning is done, this is the main part which will be happening in the reinforcement learning. So in which we will first train a reward model. Reward model generally can be any other model for that matter, which is different from the basic model that we have trained. So in this particular model, what we basically do is, so we will first we will take the data sets. First we will take the data sets where there's a acceptable answer and rejected answer. So this is the for example accepted answer, and this is the rejected answer. So for a given prompt, we'll be having the accepted and rejected. So our model, a reward model will be trained. For example, it can be BERT or any other model for that matter. We can train that model. So and loss is calculated for this model and back propagated. So this is how first we will train the model, and later this model will be used together with the basic large language model that we have trained initially. So basically, once we train the reward model, what we exactly feed to the reward model is it will be actually trained as a classification based model where we will be feeding the accepted ones and the rejected ones. So both will be feeded as the inputs, and one after the other iteratively. So then we will calculate the loss for each pair of accepted and rejected, and then we will calculate the loss and we will back propagate it. So basically after that we will train a policy for the proximal policy optimization, where we will be having the frozen model, and also the model that which we have which will be the similar to the exact basic large language model along with the reward model. So what exactly happens is we will tune the basically this proximal policy optimization model based on the reward model for each prompt sent as an input to the large language model. And why we also have the frozen model is because we don't want to this model, which is a proximal policy optimization model, to create the junk as an output. So still we will consider the frozen model while calculating of the loss, so that it won't get overfit and start giving the junk values. So this is the basically proximal policy optimization model that which we will be using in the case of the large language models. But recently one more method has come, which is nothing but the direct preference optimization. This method is actually instead of having the proximal policy optimization model, we will be training the model along with the reinforcement learning. So let us see the how this process goes. So actually what happens is in case of the So actually what happens in direct preference optimization is basically like we will skip the explicit reward estimation and reinforcement learning steps, and DPO learns the policy using the single maximum likelihood objective, bypassing the reward modeling process entirely, and this made by actually the leveraging an analytical mapping from the reward function the optimal policies. So like the DPO approach allows the policy network to represent both the large language model and the reward itself. So despite having the complex in this part, in this case of the direct preference optimization, what we exactly do is the gradient of the loss function actually increases with the likelihood of the preferred completions, and also the likelihood of the loss functions which will be decreasing based on the dispreferred ones. So this is how the direct preference optimization identifies the mapping between the large language model policies and the reward functions with the simple cross entropy loss, which is used in the this kind of the reinforcement learning. But generally this kind of the direct preference optimization is currently being used for the smaller models, and it's able to perform better than the PPO for the smaller models, and it's to be experimented for the larger models. And particularly like what happens in DPO is the exactly the explicit reward estimation and the reinforcement learning steps. So what happens is this direct preference optimization learns the policy using the this single likelihood like maximum likelihood objective by bypassing the actually the reward modeling policy here. So this is what happens. Let me explain this function. So here if you can see, like here the delta theta which we are having is the like what we are getting the gradient from the model for the parameters which are the theta which is present inside the model. So this LDPO is the loss that we are calculating here, is the DPO loss, which is a function which will tell about the like how the model's policy aligns with the like the reference output and the preferred output. I mean the rejected output and the preferred output. So once we give the prompt, which is the X here, and YW will be the preferred completion and YL will be the like less preferred completion. So like which can be a rejected one. So like the estimation for what the data set D which we are calculating is actually the we will be calculating the gradient which is our data set D take. So it updates the based on the difference between the rewards of the these two completions, where the reward model is equal to the beta log of this pi theta y by x and the pi reference y by x. This beta is basically a hyperparameter which will be tuned, and this pi theta is the reference model which is written over here, and this pi theta is the pi theta and pi reference, where pi represents the probability of the model generating y given x. So this is how we calculate the loss here. So basically like the here what we do is we will calculate the gradient of the log likelihood of the generating this preferred completion of y with the given x. So we will calculate the difference between here, the likelihood difference between the generation of the preferred and less preferred. So here this is how we will calculate the loss, and this is how this direct preference optimization is being done. So this model of reinforcement learning, which is currently like working better on the smaller models and yet to be implemented more on the larger language models. So whenever you are developing a model like ChatGPT or for any other generative model for that matter, you should be able to induce the reinforcement learning with the human feedback. So like this kind of direct preference optimization makes it easy. Thank you so much. If you like my video,